Next example. Let's determine the volume of the solid obtained by rotating. We're going to do a different region this time. The region bounded by y equals x squared minus 2x and y equals x. About the line y equals 4. Okay. So if I give you this problem, what are you going to start doing? Draw a picture. Let's draw a picture. Okay. So looks like we've got y equals x squared minus 2x, y equals x. What should I do with those two equations? Set them equal so we can find their intersection points. Just like we started with area between curves, we're going to do the same thing here. Set them equal, find their intersection points. Move all our terms to one side, so subtract an x to both sides. X squared minus 3x equals 0. And then the question becomes factoring. What could I factor out? X. So it looks like I'm getting two solutions, x equals 0 and x equals 3. Now these should give you points, so if you plug them into any of those two functions, you'll get points. So if I plug in x equals 0, you'll get 0, so I get the point 0, 0. X equals 3, you'll get 3, 3. I think I'm ready to start kind of putting my picture together, hopefully, based on this. I think I've got enough room. I'm going to try to do it over here. Okay, 0, 0, and then 1, 2, 3, 1, 2, 3, 3, 3. Needs to go a little bit higher. Y equals x is just a line, so just connect these 2 points to get your line. And then x squared minus 2x, that's a parabola. If I plug in, I need another point. If I plug in 1 into it, I'm going to get -1 for my y value. So this parabola looks something like, I don't know this. Well, if I can draw. There we go. Okay. So the region between these two. This is my region. And now I want to rotate. Here's the other equation we haven't used so far. Y equals 4. So I'm going to rotate about that line. So let me, it's a horizontal line. Y equals 4. Okay, here's my line. And now we're going to rotate about that line. So tell me, are my strips up and down, or are they vertical or horizontal? They're vertical. I'm really close to perpendicular. So they're going to be up and down vertical. Oops, sorry. All right, so let's take my strips here. I'm in a top-bottom situation, which means I'm going to integrate with respect to x. Okay, so I'm going to note that. And don't forget, there, I rotate this around. What am I getting? Am I getting a disc or a washer? A washer again, right? There's space between my rotation line and my strip, which means I'm gonna have a hole in the center. All right, so I've got a big R and a little r I gotta figure out. So let's go down here. Let's do little r and big R. We gotta figure those out. Excuse me. So let's look at our picture. Little r is going to be easier for us to understand than big R, so let's start that one. So I think I used blue for little r. My little r is this blue line right here, little r. Okay, it's the one, the line is closest to my rotation line, not the parabola. Okay, so the way I'm going to do this is, again, break this up. Think of this as being made up of pieces. So this whole distance here from top to bottom, line to bottom here, that's 4. That distance is 4. No matter where I'm at, that distance is always going to be 4. And then this distance right here, that distance is, it's vertical, so it's y. Oh, where do I write this? It's y, but what function is that? That's y equals x. And I want to integrate in terms of x. So this little distance right here, it's x. So how do I get little r, the blue line, from these? What am I going to do? Minus them, right? Take 4, that's too much. So now I've got to subtract this red piece, this little red piece, which is x. So it looks like little r is going to be 4 minus x. Now let's find big R. Let's go back up to our picture. Big R is given by our parabola. Now, if you focus on this first part where the bump is at the bottom, it's going to be a little confusing because here y is negative. So I would just focus in on this like right side piece here. Big R is this distance here. Down to my parabola. You get it in the same way. You're going to take 4 minus this red distance here, which is given by y, but it's x squared minus 2x for this function because it's our parabola. So to get the green line, I take the big 4 and subtract this little red line here. So it looks like my big R is going to be 4 minus x squared minus 2x. Okay, so that's our little r and our big R. After you decide little r, big R, you just plug into the formula, and then it's a bunch of arithmetic that's sometimes not so nice. So in this case, let me go ahead and write down a of x first before I plug it into the integral. This is pi times big R squared minus pi little r squared. Okay? So pi big R squared negative x squared plus 2x plus 4 squared minus pi 4 minus x squared. You can maybe see why I did this simplification first. It's because now I've got to square this, which means I've got a whole lot of multiplying to do, foiling, distributing stuff. So if you square that first term, you should be getting, I'll tell you what you get. You get pi x to the fourth minus 4x cubed minus 4x squared plus 16x plus 16. And I went ahead and pulled out the pi, so minus, and this will be 16 minus 8x plus x squared. So group up your like terms so you don't have to integrate as much. So it looks like x to the fourth minus 4x cubed minus 5x squared plus 24x. All right, that doesn't look so bad. So I'm ready to set up my integral now. It's the integral of this, so I'm going to pull out the pi, x to the fourth minus 4x cubed minus 5x squared plus 24x dx. What are my bounds on this integral? Which variable am I using for my integral, x or y? I'm using x. So look back at your region. What's the smallest x value you had? 0. What was the largest? 3. 0 to 3. Okay. And then from here, we're going to integrate this. Looks like I get pi. And then what? X to the fifth over 5. What about the integral of 4x cubed? X to the fourth. 5x squared.
5x is 0 3.
Plus 12x squared. So you start by plugging in 3. Well, really 3 is all I have to plug in, because if I plug in 0, I get 0. Okay. Getting a common denominator and simplifying, that's all things I think you can probably do. So, well, maybe I'll tell you how I simplified this one, because it is kind of complicated. Look at my fractions. I have a denominator of 5, denominator of 3. What's my common denominator going to be? 15. Okay, so I'm going to multiply. I'm going to get all these fractions to have the same denominator. So multiply the first one top and bottom by 3. And then here I need to multiply by both a 3 and a 5 on top to bottom. I need to multiply by 5, 5 squared, 3 cubed. And I need to multiply by a 3 and a 5. Just in case you're curious on how I simplify this, then You could use a calculator to compute all this if you wanted, but they all have a denominator of 15, so I can pull the denominator out in front. And then I look to see what in common can I factor out. So what's the largest power, or what's the smallest power of 3 you see? 3 to the 6th, 3 to the 5th, 3 cubed, 3 cubed. I can pull out a 3 cubed. What's this? And then, yeah, that's I think all you can pull out. So I pull out 3 cubed over 15, and you're left with 3 cubed minus 3 squared times 5, 5 squared minus 12 times 5. That makes the numbers a little bit more manageable. And if you do this, you should get 3 cubed is 27 pi over 15, and this will be 17. Or 153 pi over 5.